Hello and welcome to this Marty Hughes tutorial where we will be going over some RBD workflows and some instancing workflows in Solaris. This scene that you are looking at right now, that's what we will be making. And so we've been using these assets from Polyhaven, which are free, but feel free to use your own assets if you need to. And we will of course put the link in the description if you would like to use the exact assets. So let's just get into it. Just gonna name this import meshes, just keep everything organized and tidy. So we downloaded the USD version, so there's a few extra settings you need to do for the USD objects. But you can also just download the FBXs or the OBJs, so that'll work fine as well. So use the USD import, and I'm going to name it appropriately. And there's a couple of settings there you want to turn on. So you want to unpack it to polygons, and you want to set this purpose to render. You can type that in, or there's also a drop down. So I'm going to pause the video while I bring in the rest of the fruit. So I've brought in all the fruit and I've named them appropriately. So there's one more thing. So if you check on the USD on these fruits, you can see that the name comes up with this really long name. So it's a bit annoying to deal with later on for the rendering and for the RBD sim. So I'm going to do an attribute delete and rename. So attribute delete. So I'm going to do an attribute delete and get rid of the name. So before you start the sim, just make sure that you have these attributes deleted if you're using the USD assets. So I've deleted the USD XForm, the USD material path, the USD path, the name, and the path. So now I'm just going to give it a simple name. Okay. So I'm going to go through and do the rest. So we got all the names set up. So let's just merge that in. And if you go here, you can see all the names have been simplified. Sorry. See, all the names are just a single word now. So there was also a bucket we got from Polyhaven, so I'm just going to import that as well. So USD import. And the bucket will come facing the Z direction, so we need to flip that up. So I'm going to do transform. Set that -90 should be. And also we want to do the same things we did with the other ones, which is unpack and then sets to render. So now we have the geo set up. So since we're going to be filling in a lot of fruit in here, I'm going to just make this a bit bigger, maybe like 2. So we also need to set this up for collisions. So as you can see, it's got some triangles and maybe some issues with the geo, and also it's got these gaps. So it's better to have something that's simple. You can also do VDB from polygon. Set that. And if you just reduce this, if there's no holes, this should be fine. Yeah. So we got that. And then you can do convert VDB to polygons. We don't need it to be so high res, so you can drop that down a bit. That should be good. So now I'm going to do 2 different nulls. Let's go with render bucket. Let's go with this collision bucket. Right, so now we're set with our geometries. So now let's go on to the RBD sim. So let me just copy this path from here. Let's copy that. And then we'll set up a new container. Let's call this RBD sim. object merge space diagonal. So now we have all the fruits just on top of each other, but we will fix that in a minute. So what we need is, so what we did for render is we just had like a tube to drop. We scattered the fruits on the tube and just drop that down. So I'm going to build that tube. So this you can use whatever values that you need to use. These are ones that work for our situation. So I'm also just gonna bring in the bucket and see how that lines up. See. So the bucket is a bit small, so I'm gonna reduce the radius of this a bit. Then I'll fit that. Let's put the caps on. Okay, should be good. So then I'm gonna do ISO offset. This is the pretty common workflow. Scattered is on here. So we have that. Converts that into a volume, and that let us scatter points inside the volume. You can also use points from volume, but this is a bit simple. So for now, I'm gonna raise this up a bit so that it sticks closer to the input mesh. And then now we have the scatter. Let's just go down to 150 to start with. Okay, so now we have our geometry here, our emission points, and then we have our fruit. So we need to do a few things to get this fruit to work properly for our sim. So first thing, we're going to do some renames, so attribute rename. So everything here has this name already. The fruits already have names on them, but we want to change this name. We want to change it from name to fruit type, and this will be clearer when we finish the setup. So first of all, I'm just going to change the name from, that's a primitive attribute, so I'm going to change the name to fruit score type, and I'm going to do another attribute rename. So if you go here and on vertex, you can see that the UV maps are called UV map, and Solaris needs it to be just called UV, so we need to rename these as well. So go to vertex and change it from UV to UV. So this way Solaris will be able to read the UVs properly. So now I'm going to do copy to points. I'm going to copy to points. I'm going to connect the geometry on this side and points on this side. But as you can see, the fruit is all the fruits are on each point now. So what we want is an individual. Each point should have a different fruit. And the way to set this up is to use the attribute from pieces, which is a newish node. And it's a lot more simpler than the old workflow to do this, because you would have to use for loops and all kinds of convoluted ways. But this now, just with one, you can sort everything out. And it's got some really nice modes of cycling the objects. So first input, put the points. Second input, the geometry library, which is this collection of library. And we need to tell it like what attribute it should use to, separate pieces out. So first we normally it's set to name, but we've changed the name to fruit type. So we need to put that to fruit type. And then this outputs the point class. So this goes into the copy to points on the right side. And then on the copy to points also you have to tell it which is the attribute to vary the pieces. So if you do fruit type, there now you see we have different fruit on the different points. And as I was saying, the attribute from pieces has some nice features where you can do patches. So you'll have one section of one fruit and another section of another fruit. You can do random, you can cycle, you can do you can use another attribute to drive that, but for our case we're just going to use random. So now we have all the fruit on here, and we just need to do a bit more randomization. So we're going to do attribute randomize, and that's going to be, we're going to do the orient. So this is a built-in attribute that you can use, and this needs to be 4 dimensions because it's quaternion. I think that's how you say so once you set that to 4 dimensions, it will randomize the directions of the fruit. So that's that one, and then we need to do another one for the p scale. So we don't want so overall I want them to be a bit bigger as well, and just scale. So overall I want them to be a bit bigger, but I also don't want them to be too tiny, so it's just going to leave from 0.9 to 1, so it's a slight variation. And you can see like we have some overlaps on the fruit, and when we increase the point count, we're going to have even more overlaps. So for this, we're going to use a little attribute later on to fix this. But for now, it's going to leave it like that. Actually, the RBD sim is clever enough to realize that these are overlapping in the first frame, and it won't cause them to explode out like it used to do in the old days. So now, but there's also another thing you can do, which I will show you in a sec. So we have that, and then let's I think that's good. So we need this later on. So I'm just gonna put a null here to keep things tidy. So tower of fruit, we got our geo at the bottom. So this bucket is looking a bit small now, I think. So I'm just gonna increase the size of the bucket a little bit. So from, what did I have? 2, so maybe almost to connect that shit to it. Okay, because we're gonna fill it up quite a bit. So let's. If you go here, you see each fruit has the same name. They're all called kiwi and apple, but they need to be a number. They need to be differentiated for the RBD sim. Normally, when you fracture something, it'll automatically give each fracture piece a different name. But when we're doing this, we have to set that up ourselves. What we need to do is put an assemble down and then set that up. So put an assemble down. We have, and then what we're going to do is create back primitive. So then you're going to have a name with this number on it, and you also have, you see each one is called piece 0, 1, 2, 3, 4. So I'm just going to change that to let's change that to fruit. So each fruit now has a different number. So what we need to do is combine it with this fruit type that we have to get the name. So I'm going to make sure that I'm transferring the attributes over. So I need the fruit type. Right, so we're going to use a bit of Vex to combine these two names together. So do attribute wrangle, and what we need is this, call this fixed names, and then we're going to set the name to. So we need a string attribute. We are going to change the string attribute called name, and that's going to be the string attribute called fruit type plus, and then this is for to have an underscore plus s at name. So I take the fruit name is the fruit type plus the current name combined. It's basically what this is saying, and we are running several points. And now when we go here, see each fruit has its unique number. So this will be, so the RBD sim will be able to work with this now. So now we have the name set up. We're going to drop down an RBD solver, and then your geo goes into the first one, and then your collision goes into the fourth one. So the first thing I like to check is whether this collision object is being represented properly. So if you go to the RBD bullet solver and you go to the Viz tab and you turn on show collision shape, then you can see that it's bringing it in as a concave shape. So what we need it to be is a convex shape, otherwise the fruit are just going to bounce off top here. So if you go to the collision tab, then you can change the collision geometry from convexal to concave, and now that looks correct. So now I'm just going to pause the video and let this run, and we'll see what we get. So the sim is working fine. Everything is going in as it should. All the collisions are working. We don't seem to have any craziness at the moment. I'll talk about is the overlapping fruits. So for this scenario, it's fine because we're just looking at the bucket and we don't really look at the fruits. But in case you needed to have a look at the fruits as well, like your shot was that, the fruits are visible in your shot, then you want to be able to separate these out. So what you can do is there's a little Vex code that you can use, and a bunch of people have covered this, like CG Wiki has an entry on this, and also I think Paul Essevis did a video. So if you are interested to learn more, you can check those videos out as well. So what you need to do is write a little bit of Vex, and what code is I at found overlap is equal to 1. And that will go here, and then let's run that now, and you should be able to see on the first frame that these guys would split apart. So that was quick. So see here, see they split apart, and there's some others that were intersecting that we didn't notice that they also split apart. So over here. So if you needed to pile a bunch of things together, this is a good way to get rid of intersection. So you could just do a quick sim of 2 frames and then freeze it, and then you would have a perfectly set pile of objects. So that's the first thing to do. And now the other thing so when you're doing RBD sims, one of the issues that you have is that you can have like jittery sims, and usually when there's small pieces, they won't stop spinning or they'll keep moving uncontrollably. So there's a few ways you can deal with that, which I'll show you now. I'm going to run this sim and see if I can find a problematic piece, and then we can try to tame it. So if you look down here at the sim, you can see that some of the pieces they continue to move even though they should really be settling. And in this case, it doesn't really affect the visuals because they're hidden inside the bucket. But sometimes when you have them outside and they keep moving around, it's a pain to control. So there's a few techniques that you can use to control how these RBDs settle down. So there's a way to you can set them to be inactive over time based on some thresholds, and we can also apply some drag based on some time thresholds, or you can set time thresholds at a specific frame, or you can set up some speed thresholds. So I'm just going to show you that. So in order for attributes to be calculated at every time step, we need to put them inside a subsolver inside the RBD solver. So we're just going to dive into the RBD bullet solver and put down a subsolver, and that will go in here to post solve. And in here we're going to do a bit of Vex. So we're going to do some if statements, and the first one is going to be to wrangle. And so if you're wondering why we're running these over points, it's because the RBD stem is actually using the points and the proxy geo to do the sim. So you can set attributes on the points which will be respected by the RBD. That's why you can use like pop wind and stuff like that inside the RBD solver, and that works. So this is run out of points, and then the first if statement we're going to make is we're going to calculate the speed. So if the length of v at v, so vector at v, is less than, I'm going to just put a value for now, I'm going to check this in a bit, less than 0.16, then I want it to apply. So if this condition is met, if the length of the vector is less than 0.06, then we want 0.16, then we want it to multiply the velocity by 0.9. Sorry about that. Typing 0.9, and this is for the linear velocity, and this, and W is for the rotational velocity. So we need to set, so we multiply that as well by the same similar value. So you can try different values depending on how troublesome your sim is, right? So we have this. So this is the first condition. Okay, so this is going to check if the velocity is less than this value, then it's going to try to slow it down further. And we can also do another condition if length, same thing, so the length v at v, so brackets for that, that's the function, and that's the value we're targeting, and then is less than, so this is the second condition. So let's make this less than the first one, right? So if it's even lower, then we want it to be inactive. So if you've never done an if statement before, the first bit is your condition or your threshold, and the second between the curly brackets is what you want it to do. So I recommend, if you want to look this up more, check out the Joy of X on CG Wiki. Equals 0. So basically we're telling it to be inactive. So if it's inactive, it'll just act as a collision object, but it won't be moved by the sim. So now we have these two conditions set. So let's see how it's affected our sim. Okay, so now I have the two versions of the sim cached out here. So this one is with our little Vex code. And you can see that you might be able to see that things are settling down quite well. And then this is the old one without the Vex. So you can see like there's one guy here that's going a bit funny. And then over here, see they're already settling down. So in this sim, it's not very apparent, but it definitely works. The first script we did, the first wrangle we're using, it's going over, it's using the speed threshold to set the conditions, right? So but the other way you can do this is just by time. So at a certain frame, you can say do another attribute triangle, and then this one I'm going to set. So what we've set up here now is that after a certain point, it will, after a certain number of frames, it will start slowing down. So because time is in seconds, so, and my scene is set to 24 frames a second, it will, around 24 frames, you all start slowing down. So let's see what that does. And that might stop them from entering the bucket altogether, because that's quite an aggressive stop. So the other thing you can also do is instead of slowing it down with the drag, you can also just set the active to 0. So I'm going to make a copy of that, and I'm going to just name these so that this is slow by speed by vel, and this is slow by time, and this is inactive time. So let's try this one. So if we set it to be, instead of this, we do I at active equals 0. Let's see if that's correct. Okay, so let's see what that is. So you can see we set it to stop around 1 unit of time, which is 24 frames. So at 24 frames, you can see they just stop. So you could set this to something higher so that when closer to being settled, it could stop. So now we have 3 ways to control the erratic particles that may happen with an RBD sim. So we have slow by velocity, slow by time, and then make them inactive by time. And there is a way to visualize the inactive state. So if you go back up to the bullet solver, in the visualization tab, there is this show active in green, but this is not always working. So we've made a little visualizer with the Vex to be able to visualize the active state. So it basically just sets the color from white to red when it's inactive. And then in order for this to work, you also need to make sure that on the RBD bullet solver in the output, in the attribute transfer, you have the active value being transferred over. So you can see they turn red as they go inactive. So that's all for the RBD bit. I think we got everything set up now, so we can cache out these points and then we can bring them into Solaris for rendering, which we will talk about in the next video. And so you can also, so we are saving out the points, and then the way you can also check to see if this is working by using this transform from pieces. So what this does, it takes the points from here and takes the mesh, and then it applies the motion onto the mesh, to the meshes. So using the name attribute that we stored earlier. So you can see this is working quite nicely. And then what it needs is basically just the points, the geometry, and then it needs a rest position. So you can just time shift the first frame after your. So this is the end of the first part where we went over setting up the RBD sim. In the next video, we will go over rendering it in Solaris using the instancing workflow. If you liked what you saw, please drop a comment below and let us know what other topics you would like us to cover. We hope to bring some more tutorials for you, so please like and subscribe to our channel to support us. Thank you for watching.